So for relevance of my problem, the speed of light is used in formulating high-speed internet. In an earlier section of this project, I mentioned that engineers are vital for understanding and creating new ways to provide better internet.
So for the relevance of my problem to the speed of light, I chose to calculate the radio signals used to communicate with stations in space and on Mars. So in order to communicate with space stations, you have to understand the speed of light for these calculations. The timing of these signals is how we not only communicate with the spacecraft, but navigate them as well.
Alrighty, this is my relevance of problem for the speed of light. A pulse of light travels through air, water, and gas. The distance for each medium is 3.00 times 10 to the eighth power meters. The time it takes for light to travel through each medium is different due to the medium's density. This unique problem relates directly to the speed of light by showing how light travels through different mediums and how its speed can be calculated numerically. Unlike conceptual or multiple choice questions, this problem requires actual numerical solving using.
Benefits of this problem are learning the steps to understand how fast signals can travel. Skills gained are conversions, knowing the constant for the speed of light, and understanding how to calculate the speed one way and round trip, as well as combining different cable lengths to the speed of light to calculate like the difference between the two. One problem that could be solved after learning this specific problem is time dilation.
One of the benefits from understanding my problem is it connects what we've learned in physics to understanding real NASA engineering. You'll understand that the speed of light isn't just another large number to remember, it's the basis of how we communicate with absolutely anything in space.
Okay, and benefits of the problem. Understanding this problem helps students see the practical application of the speed of light, such as in fiber optics, astronomy, and communications. Solving it develops skills in algebraic manipulation, unit conversion, and scientific reasoning, while reinforcing conceptual understanding of light behavior. After mastering this problem, students can tackle related problems like calculating light travel time across astronomical distances, comparing speeds in various mediums, or determining time delays in signal transmissions.
So since section 13 of this lab was on relativistic speed and time dilation, it helped me understand how to calculate the speed using the constant for the speed of light. I am also currently looking for new internet service and it reminded me that the speed of light is relevant to high-speed internet. It's not too simple. My problem is not too simple because it requires understanding conversions, knowing the constant for the speed of light, and the formula to calculate speed. It isn't difficult because it only consists of 4 simple steps. At first, I had a hard time thinking of something that everyone would understand, but after going over section 13 of the lab, I thought that this would be a good question to use for my project.
In order to build a complex problem about measuring communication with space, I divided it into 3 parts. So the first part of my problem is how far the signal needs to travel. And then using the round trip time, you calculate the experimental value for the speed of light. And then the end is you're going to calculate the percent error of the experimental value.
The development of the problem. This brand new problem is directly connected to the topic of speed of light because it shows how light travels through 3 different mediums, air, water, and gas, and how its speed changes depending on the medium's density. Even though the distance remains the same at 3.00 times 10 meters, the time it takes varies, allowing students to see the numerical effect that different materials have on the speed of light.
My problem is unique because it consists of simple steps, double to show comparison between 2 individual facts. And to differ from time dilation, I use length instead of mass. It goes above and beyond common problems because it involves real world scenarios. Also, most people don't know that cable length contributes to internet speed, so they get a fun fact by learning my problem.
So the uniqueness of my problem is that it uses many of the techniques that we've learned in class, like percent error, And it also gives you an understanding in the nature of communicating with space, which is something that's not very well known and might be interesting to a lot of people.
The uniqueness of this problem. This problem is unique compared to common textbook or internet examples because most problems only focus on the speed of light in a vacuum or ask for basic one-step calculations. My problem goes beyond these standards examples by having light travel the exact same distance through three different mediums and require the student to compare how the time changes in each one. This adds an extra layer of application that typical problems don't include. I made it different by incorporating multiple mediums is emphasizing how density affects the speed of light and requiring the use of time formula three separate times instead of one.
A set of internet cables all transmit signals at 3/4 times the speed of light. The cable lengths vary from 1,000 kilometers to 10,000 kilometers. Kayla's cable length is 6,000 kilometers. Marcus's is 7,200 kilometers. What is the connection between cable lengths and transmission time? The longer the cable, the longer the transmission time is. This graph exhibits a linear trend.
So the visual for my problem is a graph that compares the actual round-trip communication path to the theoretical distance light travels over the same time. It highlights why precise knowledge of the speed of light is essential for timing, navigation, and reliable space communication.
For the visual for the problem, to better understand how light behaves in different mediums, I created a table comparing the speeds of light in air, water, and glass using their refractive indexes. Air has a refractive index of 1.00, water is 1.33, and glass is 1.50. These values help determine how much the speed of light decreases in each medium. The data shows an inverse relationship, meaning that as the refractive index increases, the speed of light decreases. This visual makes it easier to compare the three mediums and clearly show why the time required for the same distance changes depending on the density of the material.
The formula used for my problem is delta T equals D1 minus D2 over V. Delta T is the change in transmission time, which will be in seconds. D equals cable length, which will be in meters. So D1 equals cable length 1, D2 equals cable length 2. V equals the signal speed in the cable, which will be in meters per second, meters over seconds. Also, V is the amount of the speed of light times the speed of light. So it will be 3/4 times the speed of light, which is 3 times 10 to the 8 meters per second. And once you solve that, you can put in you can fill out the rest of the equation. The formula can be rearranged to solve for regular time. So time equals D over V. Cable length, you can solve for cable length. D equals V times T. And signal speed, V equals D over T. Something that's good to know, the speed of light is a universal constant.
The formula that I used for my problem is, first we're going to multiply the distance one way by 2 because we're looking for the round trip. And then to find the experimental value of the speed of light, we use the B equals the distance divided by time. And to find the percent error, we use the formula that we learned where you take the experimental value minus the accepted value and divide it by the accepted value times 100% to see what your percent error is.
The formula that you need to solve this problem is time equals distance light travels, V, speed of light in the medium, and T is the time in seconds.
Now the solution for my problem. What is the difference in transmission time between Kayla's 6,000 kilometer internet cable and Marcus's 7,200 kilometer internet cable if they both operate at 3/4 times the speed of light? First, we're going to convert kilometers to meters by dividing by 1,000. So 6,000 kilometers divided by 1,000 will give us 6.0 meters, and 7,200 kilometers divided by 1,000 will give us 7.2 meters. Next, we're going to multiply the operating speed by the constant for the speed of light. Remember, I said V equals the speed of the operating speed times the constant for the speed of light. So this will be 3/4, which is 0.75. So 0.75 times 3 times 10 to the 8 meters per second. This equals 2.25 times 10 to the 8 meters per second. Now we're going to subtract Marcus's and Kayla's cable lengths. 7.2 times 10 to the 6th minus 6.0 meters times 10 to the 6th equals 1.2 meters times 10 to the 6th. Now we have to divide the 1.2 meters times 10 to the 6th, which is Marcus's and Kayla's difference in length, and we're going to divide by the operating speed times the speed of light. So V, which is 2.25 times 10 to the 8th. That gives us 0.0053 seconds.
So the solution for my problem, the total round trip distance is going to be 840,000 meters, and you convert the time from milliseconds to seconds. It's going to be 3.0 times 10 to the 8th power. And then the percent error is actually going to be 0% because we use the correct speed of light.
And the solution, the speed's air is 3.00 times 10^8. Water is 2.25 times 10^8, and glass is 2.00 times 10^8.
The graph I created to the right proves that 0.0053 seconds is the difference between the transmission speed of Kayla and Marcus's internet cables. As you can see on the graph, Marcus is at about 0.031 seconds, and Kayla is at about 0.02 seconds. If we subtract the two, we will get about 0.005 seconds, which is a very small margin of error, like extremely small, from our answer, which is 0.0053 seconds. Now, someone may benefit from this type of problem because they may want to know if they can get a shorter internet cable to run through their house to help increase their internet speed.
The verification for this problem, the speed of light is constant and it's used as a vital part of communication in space, so even if the numbers were to change, the result would still remain the same.
So the verification for the problem recap is light travels 3.00 times 10^8 meters through air, water, and glass. Times calculated, air was 1.0 seconds, water was 1.33 seconds, and glass was 1.50 seconds.